Have you ever stopped to think about what's actually happening right now? I mean, you're streaming this video, but at the exact same time, billions of other people are firing off emails, jumping on video calls, scrolling through social media. How on earth does this global storm of data not just collapse into absolute chaos? Well, today, we're going to pull back the curtain on the invisible rules that keep our digital world from completely falling apart. And hey, real quick, before we really dive in, if you're the kind of person who loves to dig deeper, we've got full notes and all the links for this explainer waiting for you down in the description. So you don't need to worry about memorizing everything, just sit back and enjoy the ride. So really, what is the secret? What's the magic that stops this incredible planet-sized river of information from just grinding to a halt? Well, it's not one single thing. It's actually a handful of brilliant, totally invisible solutions all working together 24/7 to create order out of that chaos. Imagine this for a second. You shrink down, like way smaller than a speck of dust, and you dive right inside a fiber optic cable. You wouldn't see these neat little lines of code flowing by. No way. You'd be in the middle of a hurricane, a digital storm of video streams, emails, cat pictures, you name it, all screaming past each other. Our job today is to find the hidden forces that somehow manage to tame that storm. All right, first up is the problem of distance. The internet is global, right? So how does a video that's hosted on a server in, say, Germany, get to your screen in California without a really frustrating lag? I mean, even the speed of light needs time to cross an ocean. Well, the solution is super elegant, and you are literally using it right this second. It's called a Content Delivery Network, or a CDN. And, the best way to get your head around it is to forget about data for a moment and think about Amazon. They don't ship every single package from one giant warehouse in Seattle, do they? Of course not. They have local fulfillment centers all over the place, stocked with the stuff that people in that specific area are likely to buy. A CDN is the internet's version of that. It's a worldwide network of data warehouses. And this right here is the magic of it. If you're watching this in North America, you're not streaming it from a server halfway across the globe. You're getting it from a CDN server that might just be a few dozen miles from your house. This simple but incredibly powerful idea is the backbone of the entire streaming economy. It's what makes Netflix, YouTube, and pretty much everything else feel so instantaneous. Okay, so we've solved for distance. Now let's tackle our next big problem. Security. The internet, at its core, is a public space. Just think of it like a global system of highways. Now, if you need to transport something really valuable, say your company's secret financial data, how do you do it safely on that public road where literally anyone could be watching? You use an armored truck, and that's exactly what a virtual private network, or VPN, is. It's your data's own personal armored transport. It creates this secure, heavily encrypted tunnel through the public internet. So even if you're on some sketchy public Wi-Fi at a coffee shop, everything you send and receive inside that tunnel is completely invisible and unreadable to any prying eyes. And for this to work at a huge scale, I'm talking about a company with thousands of remote employees, you need some serious hardware. What's so cool about this is it shows the heart of that entire operation, the VPN Concentrator. These things are purpose-built security powerhouses. They're basically supercomputers designed for one job and one job only, managing thousands of simultaneous encrypted tunnels. They are the heavily fortified front gate to a company's entire digital kingdom. So now we're fast and we're secure, but we've got a new problem, a digital traffic jam. See, not all data is created equal. Your boss's face freezing mid-sentence on a video call is a much bigger deal than a system update downloading a little slowly in the background. So how does the network know what to prioritize? The answer is this invisible traffic cop called quality of service, or QoS. Think of it like a highway with a high-priority carpool lane. The network is configured to see that your video call is super sensitive to delays, so it waves it into the fast lane. That big file you're downloading, it can wait in regular traffic. That background update, it gets the slow lane. It's all about making sure the most important data gets through first, no matter what. And the crucial thing to understand here is that this is all deliberate. This isn't happening by accident. It's a set of rules, often called traffic shaping, that network engineers literally program into the routers and firewalls. They're actively sculpting the flow of data to make sure your most critical applications always have a smooth, clear path to run on. All right, this brings us to our final and honestly, maybe the weirdest problem of all, the problem of infinity. A computer will do exactly what you tell it to do, even if what you're telling it is to do something really stupid, forever. So what happens if a tiny little packet of data gets bad directions and ends up in an endless loop, just bouncing between 2 points for all eternity? Now, this isn't just some theoretical idea. It's a real-world glitch called a routing loop. So a data packet gets to router A, and router A sends it to router B. But because of some misconfiguration, router B sends it right back to router A. Without some kind of failsafe, that single packet would bounce between them millions of times a second, forever, creating a useless storm of traffic that could actually crash the whole network. The solution to this infinite problem is deceptively simple. Every single packet of data that gets sent across the internet is born with a lifespan. It's just a number stamped right into its code called the time to live, or TTL. And a lot of the time, that number is something like 64. And here is the genius part. Every single time that packet crosses a router, that's a single hop on its journey. That number ticks down by 1. So it goes from 64 to 63, then 63 to 62, and so on. You can think of it like a mission timer on a space probe, or maybe like a non-refillable fuel tank. So what happens to our poor little lost packet stuck in that infinite loop? Well, with every single bounce, its TTL value drops, and eventually, it hits 0. The moment it does, the next router it reaches is programmed to do one simple thing: delete it. Just drop it. The packet vanishes, the loop is broken, and the network is saved. It is literally a built-in self-destruct switch for lost data. Now, a quick but really important point of clarification here. The term time to live actually has 2 different meanings depending on what you're talking about. For routing data packets, like we just saw, it's a countdown of hops. But for the internet's address book, the DNS system, it's actually a countdown of seconds. And this quote from Professor Messer explains it perfectly. When your computer looks up a website like google.com, the DNS server gives it the IP address and basically says, okay, remember this address, but only for the TTL, which might be 300 seconds. For those 5 minutes, your computer doesn't have to ask again. But once that time is up, it throws out the old address and asks for a fresh one, just in case anything's changed. It's a simple rule to stop us from using outdated information. So let's just step back for a second. When you start putting all of these pieces together, you really start to see it. This seamless, instantaneous digital world that we all live in, it's not magic. It's a masterpiece of engineering held together by these invisible, ghostly rules that are constantly and silently managing the chaos for us. It's truly an unseen symphony, playing out trillions of times every single second. You've got the CDNs acting as the local couriers, solving the problem of distance. The VPNs are the armored trucks, solving for security. QoS is the traffic cop, solving congestion. And TTL is the ultimate failsafe, solving the problem of infinity. Together, they are what tame the digital storm. And that leaves us with a pretty provocative final thought. Our entire digital existence is built on this foundation of invisible rules, many of which were written decades ago for a very, very different internet. So as our world becomes exponentially more connected, with AI, the metaverse, and technologies we can't even imagine yet, the big question is, when will these old rules finally break, and who gets to write the new ones?